Hello programmers and welcome back to yet another Kotlin for Noobs lecture. I am your host, codingPotato. In this lecture, we will be creating our Kotlin project, which we will be using throughout this series to practice all what we learn using IntelliJ. We will also be having our first set of exercises and even make a simple game. Now previously, I uploaded a couple of videos showing you how to install IntelliJ on both Windows and Ubuntu Linux, and we reached up till this point where this is the starting page of IntelliJ. Here you can see a list of all your projects if you have any, and you can also see a list of your Eclipse projects if you are using Eclipse and have some projects on your drive. Now, to create a new project, you can use this button right here, or you can import also projects using these two buttons. So we will start by creating a new project, just like this. And over here on the left side, you can see a list of templates that you can use to quickly create a project of a specific type. We will not be needing to use these. We can just create our project straight away. Now the first thing we have to do is give our project a name, and I will be calling it Kotlin for Noobs. And as I said, I will be uploading this same project to GitHub, to the GitHub repo, and you can get the download link or the link to that from the description as usual. And this project will contain all of the exercises from this point until the end of the series. The location is where you want to save this project. I'll just keep it on my desktop for now. You can change this if you want. And the language, of course, is Kotlin. For the build system, we will be using Gradle. The book that this series is based on uses the IntelliJ build system. However, I would like to show you guys how Gradle works, and I would like you guys to get familiar with it because Gradle is what is used in Android. And since this course or series prepares you for Android development, why not practice using Gradle then? So the JDK is the Java version that we downloaded, of course, and you can select it from here, which is Java 17. And we don't need to change anything else from here. We just hit on create project and it will start creating our project. And then we have the main window right here. You can see that it's loading a couple of things right here at the bottom right corner, and we will just let it do its thing. This is mainly for Gradle. So right here you can see this is known as the Project Explorer, which has all the files and folders, the view for all the files and folders of your project showing here, so you can navigate those files. So a couple of things that I would like to show you before we start is the Gradle files. So we have this file, the build Gradle, and we have the Gradle properties, and we have the settings.gradle. These files are for the Gradle build system. We can put our configuration and settings in these files to modify the Gradle settings. So in this file, settings.gradle, you can see the project name, which we called Kotlin for Noobs. In this file, we can see the code style settings. And here, the build.gradle, which is the most important file of them all, we can see the plugins that we are using. Now, these are Gradle plugins that we use in this project. And what these plugins do is that they give us Gradle options to, for example, like here. So if you're using the Gradle Kotlin plugin, obviously because we are using Kotlin, you will get this section here where you can set up your Kotlin settings. You have your group and the version of your application. So if you update your application, this will become 2.0. You update it again and you set this to 3.0, stuff like that. Now the repositories are where you get your dependencies from, and we have Maven Central right here, and we will keep it at that. The dependencies is what's really nice about Gradle. So the dependencies are like libraries. So let's assume that, for example, you go on GitHub and you find a Kotlin library that allows you to do a specific thing. Now, instead of downloading that library from GitHub and putting the files for it in your project files to use it, you can just give the link to that library on GitHub here, add it here using the implementation keyword, and it will tell Gradle to automatically download that library and add it to your project, and you can use it immediately. You have the tasks. These are the tasks that you use to run, build, etc. of your project. So we will come back to this later because we will be actually modifying this a little bit for our project. And let's have now a look at our project files. So the Gradle file here, we don't need to look at. The idea file is the file that contains the IntelliJ settings for your project, or this project specifically. So if you change the code style or you change some editor settings, they are project specific. Another Gradle file, and our file, which is the SRC. The SRC folder or directory is the folder that is known as the source folder. The source folder contains the source for all of your code, and if we open it, we will see two folders or directories, the main and the test. Usually we work with the main, and in main we can see two directories. We have our Kotlin directory and our resources directory. In the resources directory, obviously you add your resources for the project, for example, images, audio files, stuff like that. The Kotlin folder finally contains our Kotlin files, classes, etc. We have some controls here. These are to expand and to collapse all of these trees. So that is nice to have. And by the way, IntelliJ recently updated their UI. So this is the latest version of IntelliJ with the new UI. And that is nice that they did it now, because we can practice using the new UI, and this series or course will be using the latest and greatest, something like that. So let us start by creating a package. Now a package is where we put all of our classes for the project. So you can have multiple packages to organize things in your project, but for now we will have a single package. Now a package usually starts with the group name, which is com.codingPotato.kotlin for noobs, as I'd like to have it for now. And pretty much you can have your package named whatever you want, but I'd like to keep it the same as the group name, which is the standard. So in our package, we create our files. For here, you can right click new Kotlin class or file. Now I know that we did not cover classes yet, but since this project is the project that we will be using up till the end of the course, I would like to start with using classes from now. I will give you a brief introduction or explanation about classes so that you kind of know what you are doing, but don't worry, because we will not be doing very class specific programming right now, or object oriented programming. So for the class, usually with any application you have the main class, which will be the main class of the project, and it will house the entry point function of the program, which we know is the main function. So I'll hit enter or return here, and just like that we have our file main and our class main. The package keyword only indicates to the compiler that this class or file goes in this package, which is the package that we created right here. And this is how you create a class. Essentially, you have the class keyword followed by its name, and you have the scope, as we know, which is between two curly brackets. So now, even if we put our main function in here right now, it will still not work, for a very simple reason, because Gradle does not know that this class is what is supposed to run as the main class. So to do that, we have to configure our Gradle project. We just go to our build.gradle.kts, and right here in the plugins, we actually need to add the application, the application plugin. This plugin will allow us to set the entry point of the program. So after you do that, you hit on reload or load Gradle changes. so that it does its thing, and we can use the application setting, and we can just, after it's done, we can add application, and in here we will just give it the main class name instruction, and we will give it the address of our class. So to get that, I will right click on main, and I will copy the path of this, and I will copy this one, path from content root, and I will just paste it, just so that I don't have to type that much. And you don't need the .kt, just need the main, and replace the forward slashes with dots, just like that, so that it's a reference, a package reference to the main class. So com.codingPotato.Kotlin for Noobs.main. So this will point Gradle to the main class, and we just load the changes again, give it a second to do its thing, and we are done here. That's all we need to do to set up Gradle. Alright, so let's start now by adding our main function. So in here, we actually need to create an object. The main function is a static function, and we don't need to explain that right now, but let's just say that this gives it priority or makes it visible everywhere so that it can be accessed. So let's create our companion object, and it's already giving us suggestions. We give it the scope inside the main class, and then we can create our main function, but we also need to give it an annotation. An annotation is something like this. Looks a little like this at JVM static. It's already giving us suggestions for that. Now, this annotation is called a compiler plugin annotation. It is used to generate static methods in Java bytecode for functions that are marked with this annotation. And the companion object is a singleton object that is defined inside a class, as we can see here. It is used to define static members of the class, which, like I said, is the main function. And those can be accessed without creating an instance of the class. And we will understand a little more when we actually get into classes. So let's just say that these are static and can be accessed easily without creating an instance, which means that I do not need the class or the object that is based on this class to be created. So we can just do function fun, the keyword we know, main, and give it the scope. However, the main function takes arguments. So it's done like this for now. Array and of type string. Now I will show you the terminal to explain what this does really quickly. If you remember, when we gave a command, for example, Kotlin, technically any command. So for example, if I say cat, now cat is a command that, or ls, let's do ls. ls in Linux is a command that that lists the directory contents. So for example, if I have a folder, I'd like to see its contents, I can do ls, for example, dash system. So these are the directories inside my system directory. Now this is known as an argument. Most commands, or all commands almost, take arguments to run. So this will be useless, this program ls will be useless if I don't have an argument to tell it which directory to look inside. So these arguments actually can be used with our application, and they arrive here as a parameter, and we can actually use them, but let's not worry about this because we have to add it for it to work for now. And in our main function, we can do a small test by doing a hello world message and print it out to the console, hello world. We can do also a second message, println, and we can do welcome to Kotlin for Noobs. Alright, we save this, and now we would like to run it since it's complete. However, we need to create a running configuration. To do that, you click here and you choose edit configurations. These configurations tell Gradle what we want to do with the task, with the run task technically. So we click on the add button, and then we look for Gradle. It's right here. I click on it, and then in the task I just type run, which is what we want to do with this task. So it's giving it a name. It's called Kotlin for Noobs run. Some other tasks include build, which builds the program, and a couple more that we don't need to look at right now. So we click apply, okay. And as you can see here, it changed to the task that we created, which is Kotlin for Noobs run. And if it's not selected, you can just click here and you will find it somewhere here in this list. This is actually a list, and you just select it. And now you can just hit run anytime, and it will start building the project and then running it. So as you can see here, it shows you some stats, the build successful and all that, and we can actually hide some of those by adding to the task. Let me just show you. Edit configurations, the one that we just did, and after run we give it an argument, which is -- warning mode, and we type none. So this is an argument, and we run it again, and this time it will have less clutter at the bottom. So see right here, it's actually less information. And here is the output of our program. It says, hello world, welcome to Kotlin for Noobs. So we can do some other things. For example, let's print out the result of some addition. These are the commands that we had a look before the first lecture, and here you can see it became hello world, welcome to Kotlin for Noobs, and then 15. So right now we can start with our exercises. But before we do that, and before I forget, let us talk a tiny bit about objects and classes. So what we have is our class file, and we have our keyword class to create it, and we have its scope between curly brackets. And right here we have all the functions and variables that belong to this class. And this class file is used to create an object. As we can see here, let's say that this is our object. And the process of creating an object out of a class file is known as instantiation. So using this process, you convert your class file into an object, and an object is known as an instance. This object here is an instance. What is it an instance of? It's an instance of this class. So a very common example to understand object-oriented programming, object-oriented. Now, object-oriented is an idea that says, as I said before, that everything can be an object. Everything is an object. And the example we have, for example, a zoo. So this right here is a zoo. And in the zoo, you have animals. For example, you have sections in your zoo. So let's say that we have 2 sections. So let's say that we have right here tigers. And let's say that we have, what else? The monkeys. Right here. So what is common between tigers and monkeys? Now, both tigers and monkeys are objects. Let's say that these are our objects right here, the tigers and the monkeys. What's in common between them is that they are both animals. So this is the animal object, animal, singular. So this is the animal object. And using the animal object, I can create different animals. For example, the tiger and the monkey. So one object can be the base for different types of objects, etc. of course. And these objects add up to the, how do we call them? Let's say that this object has some properties, and the tiger and monkey object add properties to the original object. So for example, this can say that a property, so let's say that this has some basic properties like it can walk and it can jump, some basic properties. So what these can add, for example, in addition to walking and jumping, let's say that monkeys can jump high. So this is a new property. And for example, the tiger can run fast. So this is a property that it's adding. So this is the whole idea about object-oriented programming. It says that everything is an object, and one object can be modified to create some other special type of object of the same type. So still, so when you do instantiation, if you check the monkey object, it's still an instance of the animal object. And this is also still an instance of the animal object, as well as being an instance of the same class that they are, the tiger and the monkey. So that's how instantiation works, and that's how you can have instances that are the same type of the super object, which is this one right here. So, and these properties, of course, are saved here. For example, let's say that variables, this is just some pseudocode. So let's say the variable jump, the variable walk, and of course you can have functions. So for example, let's say a function for the animal that can allow it to eat. So this is a function, and it has the code to make the animal eat. So this function right here, whenever you call it, it will make the animal eat. And of course, it will be part of these, since these are also an instance of the main object, which is animal. And you can also call this function from any of these two objects. All right? So all that we need to know for now, of course, we will discuss this in more detail when we get to classes. But all that we need to know right now is that we can have functions in our objects, and we can call these functions to do a specific task. We also talked about static functions, or not variables yet, but we had a static function, which is the main function. So why did we have the main function as a static function? Now let's say that this object has some variables. So let's say this is a person, and it has a name. Now if I have another object, and this object is our main class, the main class has the main function, and from this main function I would like to, let's say, without making an instance. I said before that when you make an instance of a class, it means that you create an object, but which means that if I want to access this variable, I will have to create an instance. So here, pseudocode, create instance of this person, and then using this instance, I can access the name variable inside. But what if I don't want to create an instance, which is the case with our main class? This is our main class, and it had the function. Let's not make it a circle so that we don't confuse it with an object. Let's make square for classes. So this is our main class right here. It's a class. It's not instantiated. So it means that we don't have an object of this class. And it has our main function. Now I would like to call this function. So this is what the program does at first. So it wants to call the main function so that it can run the code inside it, right? As it is the main entry point of our program. But it does not create an instance, so it does not create a main object. There is no main object. How do I access this function? Now, a very simple thing to do is to just make it static. Now, static variables or static functions can be accessed without instantiating the class. So without making an object. So that is the idea of static. It's the same thing if you have a variable. So let's say val name, or let's say version, and this is the application version 1.0, right? So I want to access this without creating an object or instantiating this class. I can just make it static, and then I can access it without creating an instance. So that's why we have the main function static or set to be static using the annotation at JVM static as we saw in our example. And that is how or why you make it static, and that is a brief introduction about objects and classes and how they work. So now we can continue with our exercises. So here I have a list of the exercises that we can do in this lecture. So the first one is checking if a number is positive or negative. The second one is checking if a number is even or odd. And we can do a simple kilometers to miles converter and vice versa. We can also do a calculator for the factorial of a number. And finally, we can do our number guessing game. So let us start with our first exercise. So we can remove all of this. This was for testing. And we will leave our main function empty for now. What we will do is create another class, and we will make a class for each of the exercises that we do. It's very simple. Just right click on the package, new, and Kotlin class file, and we will give it a name. So this will be lecture 3 EX for exercise 1. So this is the first exercise of lecture 3, and we can put our code right here. So the first thing is that we will create a function called, let's call it init. Init stands for, or is a short for initialize, so we can do that. So function, or fun keyword, init, and give it the scope. And right here we already did this before, the checking if a number is positive or negative. So what we will do is that we will listen to the console input, so read the input from the user, which should be a number, and we will just compare using an if statement if this number is positive or negative. So the first thing to do is read the input, and we create a variable in a val because we don't need to change this. We will call it number, which would be equal to, let's specifically specify that it's an integer, like that. And let us read line. And this will give us a string, by the way. We've mentioned this before. The readLine function returns a string, so we just need to convert this string to an integer. So not null, of course. We use the not null operator to tell the compiler that this will not return null, hopefully. And we cast it to integer. Nothing new so far. And we can ignore this error. What's this error? It's saying replace readline with readLn. We don't need to do that. So right now we can start comparing our number. So we just do a simple if statement, and our first condition would be if the number is less than 0, which means that the number is negative. So if number, our variable, is less than 0, give it the scope, we will print a message, println the number, and we will use string literals to insert the value stored in this variable into the string directly using the $, and give it the variable name number is a negative number, just like that. And then we will check if the number is equal to 0, because 0 is not negative and it's also not positive. So we will do a case for that using what we learned, else if, else if, just a little bit confused because the microphone is in my face. Else if, and we give it our second condition, number is equal to 0, and we will print a message saying println. And let me let me just zoom in just like that so you can see a little better. The lines are not very long, so we can zoom in. Println the number, and I will print the number again, it's fine. The number, and print the number is 0, and we have an exclamation mark. And also finally we will do an else. We don't need to compare anymore. So if this does not satisfy, this condition is not satisfied, and this condition is not satisfied, this only leaves us with number that is greater than 0. So we can just say println, which is positive, right? The number, and I will print the number again in the string, is a positive number. So those are all the cases that can happen with an integer, unless the user types in a word or something that is not a number, so that will result in an error, but we will not be handling that because I think we have a whole chapter about exceptions and handling them, so we will leave it at that. So this should work, right? However, it's not linked to our main function in any way. So we have this class, but we just need to run it from our main function inside our main class. So to do that, like I said, when we talked about classes and objects, we have to instantiate the object of this class lecture3ex1. To do that, we need a variable, and we'll just use val because we will not be changing this object. So val, let's call it, let's say L lecture3 E1, right, is equal to, usually we said that we use the new keyword to create a new class, if you remember from a previous lecture, just like that. However, the new keyword is redundant and therefore is not used in Kotlin anymore, so we can skip that and we can just say lecture3x1, but there is something wrong here, unresolved reference. So let me say lecture3. I think I had a typo, just like that. All right, this right here, you can, using this you can know if you are creating an object or using a class using the brackets, or these brackets. These essentially are calling the constructor of this object or the class, but we will not be getting into that. But you can just notice that there is something different here, which is these brackets here. You can pass parameters to the class using these, but we don't have a custom constructor here, so this will not show. So for now, just know that when you do this, it's creating an object of this class. So now that we have our object, the object will be stored as a whole in this variable, and we can access it using the variable name. We can do that using the dot operator. So we can just do L3E1 dot, we call our function. This will show us all the functions that are in our class. So just dot, and it will give us suggestions. Of course, there are some default functions coming from object. The default object is the super object of our objects, but we don't need to worry about that for now. So we select our init function, and this will run our code that's here. See, this changed color because it's being used. If you're not using the function, it will show a gray color. It's something nice about IntelliJ, showing you that this is not being used. Also, it will show you a warning somewhere. So that's nice to have. So right now we can run it, and this will work, right? Since everything is wired up and our code is here. So let's see. I know it's not going to run, but so we just wait for it to do its job, and we have an error. So debugging or error tracing is something very important that developers have to do. And right here you have your error. It says exception in thread main, null pointer exception. Where is this exception happening? It's happening starting from here inside the init function. So you see this is a reference to the class codingPotato Kotlin for Noobs class name.init. And if you click here, it will show you the exact line where the error is happening. The thing is, the read line here is giving us a null value. In Gradle is not set up to read the input from the console right here. It will return a null value. That's all that we need to know. So the thing is, we need to set up our Gradle to read to set the stream where it reads the data to the console right here, so we can type stuff here while it's running. And again, we can go to do that. We can go to our build.gradle.kts, and we have to modify our run task. So we can go here right under our test task, and we can do tasks.run, and we can, typo again, .run. And because we want to run some Java specific code, we have to give it the Java exec task, just like that. And then we do the scope, and to tell it to set the stream, the data stream from the console, we just give it the command standard input equals to system.in, just like that. So we have to save, Control S, of course, and we load the changes, let it do its thing in a second until this is done right here. So as you can see, the colors changed, meaning that everything is good. So when we add this, it will tell the run task, the Gradle will tell the run task to do some Java exec. The Java exec task tells it that this is a Java related code or something like that. And you just tell the tell Gradle to read the data coming from the console. So we can go back and we can run. We don't need to go back. We can run it using this button from anywhere. So it's running right now, but you can tell. So it's waiting, as per our code, it's waiting for a number. So let me give it, for example, 10. See, I can type here, it's in green, and I hit return or enter, and it will say, give me the result. The number 10 is a positive number. Nice. But I can do something that's a little nicer, a little more user-friendly, by printing a message here, and I will not use println or print line. I will just use print because I want it to stay on the same line. and you will see what I mean in a minute. So print, and I will print a message saying please enter or type a number, and I will put a small space here, and you will see why in a second. So just by adding this, when I run it now, it will say please type a number. So this is more like a console application now, and there is a space between whatever I type and the string that I just printed out to the console. So I can type -10 for this time, or any other number I want, -2, 5, 6, whatever. So it's negative. I'm just expecting it to tell me that the number -2536 is a negative number. And if I give it a 0, I run it again. And if I give it, for example, a 0, I'm expecting it to tell me, enter, to tell me that the number 0 is 0. So this is our first example. It's a very simple one, yet it's nice to do. And we now know how to fix the error that Gradle has with the input stream from the console. So now let's do the second example, which was, what was it? Checking if a number is even or odd. Alright, we also did this one. We saw that in the slide. So we will remove this from our main so that we can run our second class later. And we will create, in our package, we will create a new Kotlin or class file. And we will call it lecture 3 ex2, for example. So we have our class here, and let's make our function in it the same way. So we have our function here inside of our class. So what we will do is the same thing. So I will go here and copy it. We will take a number from the user. I will copy this and I will paste it here. It's exactly the same thing, except for the logic that comes afterwards. So we will do another if statement test. If the number, and we will use the modulus operator that we talked about, over 2 is equal to 0. This is related to math. So if you do division and you get the remainder and it's 0, the number is even. So we can print the message, println the message, the number, and string literal again to show the number that we got from the user is even. And else, we can do else, but yes, let's just do else. If it's not equal to 0, if you use else if, this will be like this, not equal to 0. So for here it's equal to 0, else otherwise if it's not even, it's always odd, just in case you don't know how to do that. If you already studied the material we took in the last lecture and had a look at the operators, you will know how to do this. The number is odd, right? So this will show us if a number is even or odd. So let's create an instance of this, val L3 E2 equals to lecture 3 E2. I can just select it to save me from typing, and my brackets, and then I can call the function from it, the init function, and we are done. If we run it, let's try it with a couple of numbers. It says please type a number. So 10, is it even or odd? Is even. And we can do a couple more. 15 is odd, stuff like that. So we are done with the second example. It's very simple and straightforward. So the third example, kilometers to miles converter. This is a little more tricky, therefore a little or more fun. So we remove this for now, and we create our new Kotlin class, and we call it Sorry again. Typing with the microphone right in front of me is not very fun. Lecture 3, exercise 3. And we add our beautiful init function. And now we just have to think a little to achieve what we want, which is to convert kilometers. Let's do kilometers to miles first. So simple math, 1 kilometer, just show you, is equal to whatever you have in miles multiplied by 1.609. So you can do the opposite to get miles from kilometers, which is divide. So using this logic, we need to read the input from a user, and we will copy it again, and we will change the message. Let's just copy it. So we are getting a number, and let's call this kilometers instead of numbers, okay? Small case. Kilometers. If you did not notice, the classes always start with uppercase, and if you have variables or functions, you use the lowercase. I think we talked about that before. And if we did not, now you know. So please type a number instead of number. So please type, let's just say kilometers, even if it's not perfect, it will work. Please type kilometers, and we get this converted, but I'm not sure that integer is the best. Let's do double, because it's a kilometer, so you can have 1.5, for example, 2.5 kilometers, 2.35, stuff like that. So it's a little more accurate. Double. To double, just like so. We casted it to double, and the type of the variable is double. And now we can just convert it, so we can print a message directly. We don't need to add extra unnecessary lines. And we can have some comments so that we practice using comments. So 2 double forward slashes, and I can say here, write a message to the user. And here, what are we doing? We are reading the input from the user and converting it to double from string. And then what do we need to do? We just need to print the result of the conversion. And this is done, println. And we can do something like string literal kilometers, kilometers, okay, is equal to, and we print the result of our calculation. So we can do a string literal again, and we can give it a scope. This is nice to practice this. We said before that if you have the curly brackets after your string literal, it will give you the scope if you need some more space to work with. So we can have kilometers multiplied by, I said it was the number 1.609 to get the miles. And after that, so anything outside of this is again my string. So after that, I will type in miles. So the string will be the number, whatever you provided, is equal to the number after the calculation in miles. So let us have a look. Okay, but before we do that, we have to add it to our main function in our main class. So val L3E3 is equal to lecture 3 exercise 3. And then we call our function inside of there, L3E3.init, just like this. And we start this. Let's have a look. Please type kilometers. So let's say I want to convert 1.5 kilometers. And it will say 1.5 is equal to 2.4 something miles. And I would like to add kilometers here. So let's go back. After the string literal, I can say kilometers. Or let's use the shortcut km. Run it again, and it will ask us, for example, 3.4 something, I don't know. And it will say this number in kilometers is equal, or we can remove the space actually. Oh, we can't because it's a string. So it doesn't matter. Okay, we have to use scopes for that, but I can't bother. Is equal to this number in miles. So this is our kilometers to miles converter. And we can also do miles to kilometers, and the simplest way to do that, so I'll be doing this the easiest way because this is our first programming lecture. So let's say that we read it twice from the user. So write a message to the user. This is the first step. We read the kilometers from the user, and we also read the miles from the user. So here we ask him to give us miles, and he can choose. He can give 0 in kilometers if he does not want to convert from kilometers. So we change this name. See, you have an error because these two have the same name. We call this miles. Double read line to double. So then we copy this. It's pretty much the same thing added below. So here we do miles, which we got from the user, and we change km to miles, is equal to, so this will be different. And here we have km before we changed it, and let's change the miles, or we have the, one second. We have, I think I am doing the opposite for miles, and it doesn't matter, you get the idea. So we get the miles and divide it by that number, miles divided by 1.609. I think it's correct. So let's try. So here it will tell us to give it the kilometers. Let's say I'm not interested in converting from kilometers, so I'll give it 0. And it will tell me type miles, and I can type something like, let's say I have 217 miles that I want to convert to kilometers. So it will give me two messages now. 0 kilometer is equal to 0 miles, obviously. And it will say also 217 miles is equal to 134 kilometers. Can I just take a second to use Google to check if this is correct? 349. Okay. We are doing the opposite. So here you take this and divide, and here you take and multiply. Let me just confirm real quick. I will run it again, and the number is 217. So 0. So it's just a calculation error. The program works fine. Yeah, now it's correct. So you take the miles and multiply it by this number to get the kilometers. So 217 miles is equal to 349, and I just confirmed using Google technically. So now it works, it's correct. The calculation is correct, and the code is correct in this case. So we are done with this example, and let's see what else do we have. Calculating the factorial of a number. And why don't I first show you what a factorial is, because I'm not expecting that all of you are. I hope that all of you understand the modulus thing. So I explained it pretty easily. So if you have the number and you try to get the remainder of 2 for that number, if it's 0, it's even. If it's odd, if it's not 0, it's odd. So this you can Google if you still don't understand, but the what was it? What are we trying to do? The factorial. Okay, so the factorial, let me show you real quick what a factorial is in math, or I don't know. Alright, so factorial, for example, let's say that I want the factorial of 5. And the factorial symbol is something like that. It's just an exclamation mark in math. So this is equal in math. If you can use your calculator if you have one to do that, or just use Google. But if you would like to calculate this manually, this will be equal to 5 multiplied by 4 multiplied by 3 multiplied by 2 by 1. So if you calculate what the result of this, whatever it could be, then it's the factorial of 5. So pretty much that is the factorial of any number. So 10 is the same, it's just longer. So that's 10 by 9 by 8 by 7, etc. So if you're already getting ideas, we can use loops, which we studied about, to accomplish this. For example, a for loop that will start at the number that we give it, at the number, and it will go down to, let's say, down to 1, or from 1 to up to the number that it's the same thing, I think. So let us just try to do that or implement that in our program. And let us do a new from our package, of course, new class file, and we say lecture 3 ex4. Okay, and I will do the init function, and let us do the factorial. Okay, so same thing, we will read the input from the user, and let's copy one that says please type a number, an integer. It can't be, I don't think we can find the factorial of a double, so numbers with a decimal point. So we have this already. Without the comments, we don't need the comments. We have the comments for exercise 3, because let's say it's a little complicated. We can close these. We are done with these. So please type a number, and to find the factorial, it's really simple. So like I said, we can use a for loop. I can't see my keyboard, but it's fine. And we can say I and give it a range. So like I said before, I is the variable that will be incremented in the loop after each iteration. So I from 1, we can go from 1, give it the range of number. So you just do 1 dot number, and this will go from 1 to that number, as we saw, incrementing the I value. So the result, to get the result, we have to create a variable, and I like to create a variable that is being incremented or modified in a loop, to create it right on top here, so I don't leave a space between them. So let's say var result, let's keep a type of long. So if you give it a big number, it will be, of course, a very huge number, and let's set it to 0 for now. Okay, let's say 0 or 1. Let's set it to 1. You will see in a minute. So because we are multiplying, if it's like addition, I can do 0 and increment, but since I'm multiplying, I'd like to multiply by 1. So then we can say the result, we want to multiply the result by the value in I in this iteration. So if we have in the first iteration, if I give it 5, for example, like I showed you, you will have 5, then multiplied by 3, then multiplied by, 5 multiplied by 4, then 3. So we can use the shortcut, the multiplication shortcut operator, which will save and multiply at the same time, or multiply then save into the variable. So we can say result asterisk equal, and then we have I. We have to cast it, I think, to long, so it will also be a long. So the result will be long multiplied by long. And I think we are done. This will calculate the factorial, and then we can print the result, of course, to the user. So we can do println and then say the factorial of, and show the number, of course, using string literals, of number is and show the result. That's it. That's enough. The result. just like that. Save, of course, Control S, and then we can see, we can run it. So we have to create the object val L3 E4 is equal to lecture 3 exercise 4, and then we can do L3 E4 dot init to run that function inside the class. And then we start our program, and hopefully, okay, so it will tell us type a number. So let's say the factorial of 5. So the factorial of 5 is 120. Let me just confirm. I think it is 120. I haven't done math in a very long time. I think, yeah, I remember that 5 is 120. It's 120, yes, I just confirmed. So our code is correct. And yeah, this is the factorial of a number. So what I'm thinking right now, this is a little too hard to operate because we have to change this here to create an object of some class and run it using the function inside. So this is a little not too user-friendly, let's say. So what I would like to do, since we are done with the simple exercises, before we start with the number guessing game, these already covered like most of what I would like you guys to know before we move on to the next chapters. So you should be comfortable with loops, using operators, using the if statements, stuff like that. That's the simple stuff. We haven't got into if expressions, or we don't need to get into it right now. So I would like, let me move to the tablet so that I can show you what I would like to do. Maybe do some pseudocode right here. Alright, so what I would like is for the program, when we start it, so this is the start, if I can spell, okay. When it starts, I would like it to print a selection. So how would the selection be? So for example, let's say that it will say hello, first of all, welcome to Kotlin for noobs, examples, something like that. And then after that, it will say, it will show, before it will say or ask, so it will show that one, the example one, it will give you the example name. So what did we have? Let me see. We have check number is positive, check number positive or negative, etc. 2. So it will show you a list. Checking even, odd. 3. So we have a list of kilometer to mile converter, stuff like that. So it will tell you hello, welcome to Kotlin for Noobs. Maybe have like some hash to show that this is the title, and then it will tell you 1, 2, 3. So it will print the selection and then read choice from user. So read the selection choice from user, and then I would like it to start the example, so you can play with it. The example, and I would like it to go back and do this again. So when the example is finished, it will or not, let's say not from here. I would like it to not print the selection again. I'd like it to just ask you to please type the choice of the example you want again. Or let's say this will lead to some issues. Let's say it will go back to the beginning. So to do that, you can already imagine what I would use. I would use a switch, or what we said is equivalent to a switch in Kotlin, which is the when So we'll read the choice from the user, which should be an integer because it's only 1, 2, 3, 4, 5, 6, and it's only a positive number. So we'll read that and compare it to the cases that we have, and then we, according to the case, we would start the program that we want, aka create an instance of the object and run it. So why don't we do that right now? This is not hard to implement at all, and we have already covered something similar to it. So all we have to do is let us copy the read line thing, just this, and we will change it a bit. So we go to our main function, and right here, instead of asking the user to type a number, we ask him to type a choice, right? And here we just have to change this to, let's say this is choice, okay? And on top, of course, we have to print our message, application starting message. So we do print a line, what we agreed on. Welcome to Kotlin for Noobs examples, just like this. And we print, let's do this as a multi-line. Okay, so this is a great opportunity to learn about this. So let's print this on a multi-line, just like that. So this is all in the argument for the print command, anything between these two brackets. So the first line would be, let us just have, so that I don't get confused, have this here as a reference, and I'll set it to show on top always. So the first one, it will be positive, so 1, choice 1, positive dash negative number checker, and we can use a plus here, and here we can put our second string. So this is a string concatenation, but after each line I want the line to break. So if I do this, this string will just show in one line as whatever I have here. To break, I can use the \n character, or we have covered this before. So this will break the line and go to the next line. And I will do 2 even dash odd number checker \n again, next line, and I can do plus to add a string. Third string would be the third choice, which would be kilometers to miles converter, plus, and let's not forget the new line. And here 4, choice number 4 would be factorial calculator plus, and I almost forgot the new line. And the last one would be 5, which is our game that we'll do at the end. So this would be number guessing game. Okay, so we have these, and before it, let us do like a because this will of course carry on with us for the next time we do examples or exercises. So I would like to indicate that these are part of lecture 3. I have the plus. Of course, if you don't have the plus, it will be just wrong syntax. And I would do, for example, hash and say lecture 3 examples. And next time we can do lecture, whatever the number of the lecture would be, examples, and continue 6, 7, 8. Okay. So here we get the choice from the user, and in the end we have to do our logic, which uses the 1. and we compare the choice. Okay, and we have the scope for this, and if choice is 1 and we have this like operator or keyword which is just dash and greater than sign, which almost which is almost a like an arrow, something like that, and we give it a scope because we want multiplies. If we just want one to put our command here, we don't need the scope, but we want a scope because we are doing two things. We have two lines, which is create an object val, let's just say object, obj, short for object, is equal to lecture 3 exercise 1, and then after that we do init, we do obj.init. There is a shorter method to do it, but I'm not sure. So let's say if I do .init here, can actually do that, and just like don't save it in an object, so in a variable. So I don't need to necessarily save the object in a variable. I'm just creating the object here of the class, and I'm calling the init, and this will not be saved in memory anywhere because there is no variable. So you guys can do either. So this is also correct. So this is shorter. So why don't we keep it at that? But don't get confused. The first one works, which is what we have been doing, and this is just the same thing. It's just shorter and saves some memory. So don't like to complicate things now, but let's do it like this. And second is the same thing, but we select, if we type 2, it will be example 2, and we call the init function that we have. 3 would be lecture 3 example 3, and we do the init, and if the choice is 4, etc. You guys get the idea, I hope. Create the object and call the function. 5 is the number guessing game, which we don't have yet, so I will not be calling it. I will type it in later. So let's follow the code and see. Let me just zoom out, since maybe we can see it. Okay, we can see it in the window without having to scroll, so that we can follow the code easily. So the first thing, we're printing a message, welcome to Kotlin for Noobs examples, and I would like to add a heart. You can do whatever you want. So this is a heart, and then we print our menu. So it says lecture 3 examples 1 2 3 4 5, and then it will print, please type a choice. So you can select your choice. It saves your choice in a variable right here, and it's complaining about something. Could be inlined. Let's not do that, just to keep things simple. And then we have our when statement. Here it is a statement, not an expression, because we are not returning anything. So the choice, we are comparing the choice, if it's 1, if it's 2, if it's 3, if it's 4, and as an integer. And we just run the class, that is create the object and run the, we don't need this, and run the init function. So let's give this a try, but this will not loop, like I said, simply because there is no loop. So it will come here, it will do what we said, it will come here, it will run the example one time, and it will stop. So let's try it for one time. Let me expand this. Alright, so you can see lecture 3 examples. Okay, I forgot the new line here. So let me stop this. You can stop it using this right here. We forgot a new line here. \n, line break, they call it a line break, something like that. Okay, so we have our menu, looking good so far. Welcome to Kotlin for Noobs examples. Lecture 3 examples: positive negative number checker, even odd number checker, kilometers to miles converter, factorial number calculator, and guessing game. And it tells you please type a choice. So I can now start whichever part of the program I want. So from the menu, let's say I want 1. I will type 1 and then hit enter. So it started, see? Very nice. See, it's saying please type a number to check if it's negative or positive. Let me do something sus. I'll do 0 because I'm just a sussy baka. So it says the number is 0. So this is our number, negative positive number checker, and it works, and it stopped. So we said that we want to put this program in a loop, and obviously the easiest way to do it is to use a while loop. So I can say while true, and I think I have mentioned this before. Let's give it the scope. So we start here and we end up here. Don't get confused, but with practice you will get used to the curly brackets thing and scopes. So it's also automatically indents it for me. Indentation is this space here. So everything that's inside this, for example, is indented by one tab character, and you can see that this is part here, and all of this, the while, is part of the main, and the main is part of the companion object, etc. So it's comfortable. Let's just zoom in back to, let's say 14 pt is good. Okay, so let us play a little bit. I will run the program, and first thing, what should we do? Let's try the even odd number checker. So that is number 2 in the menu. I hit enter, and it will tell me please type a number. To do this, 10. It's even, right? It says here the number 10 is even, and it started again. Welcome to Kotlin for Noobs. Examples. Lecture 3 examples. And again, we can do factorial calculator and do the factorial of 5. It says please type a number. And it gave me the result. It's not very pretty so far, but we can work on that. The factorial of 5 is 120, and it resets back. I can stop it only using this. And our program is complete now. It's really nice to use. We can do, to make this more visible, we can do -n at the beginning so that it gives us a new line. And let's put it in a box. You know how programmers, they say it's rice. If you know what rice is, it means like it's lame. But I know it's lame, but we are still beginners. We can do something like that, or dashes. They put like a plus sign to make the box, the edges of the box, and then a little bit here and another plus sign, and you will see in a minute what I mean. So we have a new line, so it gives us some space to know where it ended and where it's starting. And then here you put another plus sign, and you try to center this as much as you can, and then you match the, it's not a plus, it's this pipe thing, you know, the vertical line, like that. So it's like a box, and then plus. Of course, this needs to be on a new line. After this is done, I have to put it on a new line, and then here I have to put this on a new line, and then at the end I have to, I can just copy this, and I will keep the new line, so there is a space at the end here. I can remove it, and this will show directly under it. And let's do some comments. So this prints the header, and this prints the menu. If I can type, prints the menu. And here we can, let's put these on a line. Get the user choice, and at the end, choice logic. Let's say choice logic to start whichever part, and it will loop again because it's in a while. And the true, as you can tell, it evaluates the condition here. This is always true. If I put a condition which evaluates to true or false, of course it will evaluate it, and based on the result it will loop. But since I give it a true, so it's always true, it's always getting true as a condition result, so it will run forever, as we saw. And I think this will look nice. Let's try it. The only way to tell if is to try it. So I can run it. Alright, so this looks, and let's put a space here after the choice, or yeah, it will make it more visible. It will make it more visible. Maybe cheesy, or so number guessing game. And let's put this on a new line, just -n before it. It will make it more visible, I guess. Let's run it and see. Okay, now it's way more visible. It says welcome, and we have our example list, and let's choose, let's say 3 kilometers to miles. Enter. Please type kilometers. So let's say I have 10 kilometers that I would like to convert to miles, and I would like to convert 20 miles to kilometers, and see the result. Okay, this is very nice. 10 kilometers is equal to this in miles, and 20 miles is equal to this in kilometers. And it starts again, and this is way more readable or user friendly. It says welcome to Kotlin for Noobs examples in a box. Gives us the menu and tells us to select which program we want to run. So that is this. See, it was not that hard, and it's really, I'm very proud of it. So this is not really centered, or yeah, we need another one here, another one here, another one here, and sorry, space here. So it's centered. So we have two empty spaces on the left and two empty spaces on the right side. Okay, save it. And now all we have left is to start with our number guessing game, which is the biggest example of all of these. And we will do that right now. The game we want to make is not complicated at all, and it's not difficult to implement. So why don't we start by designing the game first, writing some pseudocode, and it is a very good practice in programming to write pseudocode of your program, make your UML diagrams, or even do the finite state machine. But if you don't know what those are, it's fine, because we will have a look at them later. Pseudocode is what we have been doing. It's, I think, written like this. Pseudocode is what we have been doing, which is writing the steps that your program goes through in plain English. So the game we want to make is a number guessing game. Okay. And it works as follows. So the first thing is the game will guess a number, or not guess a number, it will think of a number. The game thinks of a random number, of course. Then you will have to guess this number, so it will ask you to guess. So here, user, guess the number. And then, if the number is correct, you win. If it's correct, you win. Otherwise, it will tell you. Tell if it's less than the number that it's thinking about, or greater than the number it's thinking about. And you have, it's not a step, and you have for a certain number of attempts. So let's say 3 attempts or 4 attempts, something like that. We can, instead of doing a state machine, we can make a flowchart for now. And it's, like I said, a very good practice to design your program before you actually start implementing it. So this is the start of the game. Start. So it will generate a number. Generate number. Right here. This is the second step. And then user will guess. So get the user's guess. Right here. And then if it's correct, you will win, of course. So if it's correct, you will win. Otherwise, so this is a step by itself. And if not correct, so it will be something like that, not correct. We will tell the user if it's less than or greater than the number it's thinking about. And then you guess again. So you guess again, you will go here. Either of these will take you back to the guessing part. If I can like draw it. Okay. And this will happen for a certain amount of times if you have more attempts. If you don't have attempts, you will lose. So let's do it from here. So let's have a step, have attempts. If yes, it will tell you if it's greater than or less than. So this right here. And that's pretty much it. And the final thing would be that if you run out of attempts and you don't get it right, you lose. So very simple, straightforward. Can't like zoom out so we can see the whole thing. So yeah, the start is not really important. We generate a number, get the user guess. If it's correct, the user will win. If it's not correct, if he has attempts, he will get a message it's less than the number, or a message it's greater than the number. And if not, he will lose within these attempts. Let's do 3 attempts with our program. And I wanted to say something. I think this is good enough. This is good enough for now. So that is the flowchart. If you'd like to have a look at it, you can pause and we can go back to our IDE. So we will create a new class. Right click on our package, new Kotlin class or file, and we will call it lecture 3 exercise. This is exercise 5. And we will do our init function just like before. And we have the space here to work with our program. So the first thing we will do is print a message, a simple welcome message, println. It will say welcome to number guessing game. And the next step would be to get the user input. Or let's say we generate the number first before we get the user input. So this prints the header, and here generate a random number. Now this should be between 1 and 10, but let's keep it between 1 and 5 to make it easier to win. So we have less percentage of error. To do that, we will use val, because we will not be changing this value, and this would be called let's call it number to guess equals to generate a random number. We will have to import the random class. Let's have a look at that. So random from java.util right here, and you see this keyword here which imports the class random from the java util package. So this is a class and this is the package of this class. It's in java.util.random. When you import a class, it just allows you to use this class here in your also a class or in your code. So there is a function that's called nextInteger, which allows us to create an integer between two given numbers. So let's say if we give it 0 and 11 or 6, it will generate a number between. Let's see, reference. I think we have to instantiate the class. Or we can change this. There is another class that's related to Kotlin, so we can use Kotlin.random.random. Yeah, use this instead. This will allow us to generate a number. So use this class instead. And if you don't have it imported, you can select it, I think. So let's just try. So random, and it will let you choose. So choose the one, not the Java util one, choose the Kotlin.random. Okay. Random.nextInteger, and give it a range 0 and 6. So it will be 1 to 5. Okay, so now that we have our number, what we can do now is get the user guess. So right here, get the user guess, and this is just what we did before. Let's just copy it and paste from one of our exercises. It will say print a number, and we save it in a variable. So let's take this and we just paste it, and let's leave them right on top of each other because it's the same step. And instead it will say please guess a number, or please type your guess between 1 and 5. So this message will show, and it will save the number here. And let's change the name of this. Let's call it guess. Okay. And now what we need to do is do our loop. To do our loop, but before we do our loop, we can create a variable which will save the number of tries for the user. So we can say it or call it number of tries, just like that, and set it to 1 for now. And then we can create our while loop that will loop again and again if the user did not find the correct answer. Inside this, we'll have our condition, which would be number to guess. If number to guess, if it's not equal to the guess, then what's this? Number of guess, number to guess. So it's just a typo. If the number to guess is not the same as the user's guess, then it will loop again. And here, this means that the user failed to guess the number, okay? Here it will print a message, println, and it will say, sorry, your guess is wrong, just like that. And let's do some spaces. And then it will do some tests to see if the number of tries is still allowing the user to continue. So if we have the number of tries, this one, if it's equal to 3, so we start at 1, so he tries 1 time, he got it wrong, we try another time, so this will be 2, we will increment it at the end, of course. If this is 2, he'll try again. If this is 3, okay, if this is 3, so 1, 2 and 3, this here is equal to 3, so let's put it as 4, so this will give us 3, so 3 will be included. 1, 2, third time will allow it to run, and at 4, which is after the third time, it will break. So to break, we can just use our break command. So it's the warning here, condition is always false. Okay, it's always false, so this IDE is, or IntelliJ is a little smart. It's telling you that this number is not changing, so it's always true, which will change in a bit when we increment. So let's just increment it. So we can say number of tries plus plus using the shortcut operator that will increment this. So when this hits, if this is 1, when this is reached, it will become 2. Again, it will become 3. And now the warning is gone, as you can see. Okay, so what else do we need to do? Okay, so this says if the number of tries has reached 4, and then we have a second check, so we can do else if and check if the guess is less than. We'll now do the less than or greater than, so it will tell the user if the number he guessed is less than the number it's thinking about, or if it's greater than the number it's thinking about. So if the guess is less than number to guess, we will print a message to the user saying, println of course, it will say your guess is lower than the number. Else, of course, we don't need to check if it's because if these two conditions are covered, then it means that we only have the condition where the number is greater than the guess. So we can just println now without a condition, your guess is larger or higher than the number. Okay, so we have this covered here. And now it should, because it will loop here, it will not loop here. So we have to do this again. So we have to print a message here after these, which will say println, and it will say please guess again, and between 1 to 5. 1 to 5. Of course, our colon and a space. And then we have to change the guess. So this should be a var, because we will be changing it. So var, and it says is never modified, but we will modify it right now. See, you get a warning about that, but we will modify it. So we will read the input, or just do guess is now equal to read line to integer, just like this. So it's copy and paste. So we're changing the value of guess when this is reached, and it will increment the number of tries. And do we need to do anything again here? No. Alright, so this will happen and it will increment the number of tries, and then it will come here again and say if the guess is not, of course it will come here, if the guess is not correct yet, it will do this operation again. Otherwise it will skip the while loop and we will come down here. So do we need to comment this? Let me see. No, we don't. It's pretty obvious, I guess. So let's just comment this at the top. Operation for when the guess is wrong, or loop for when the guess is wrong. Okay. And finally, we can do an if statement where if the number to guess, or let's just do an else. Oh no, we can't do. So let's just do an if. If is number to guess is equal to the guess, or vice versa, if the guess is equal to the number to guess, we'll print a message, println congratulations, you won. Otherwise, if the user did not get the number correct, so it will print ln sorry you lost. And we also would like to print stats after you say if the user won or lost. So we can print a stats message using println. You took, and we will take the number of tries. So string literal of this. You took the number of tries, guesses to win. And here, okay, so congratulations, you won. Let's also type the number that the program was thinking of. So the number is the number to guess, just like that. And we do the opposite here. So sorry you lost, and we can copy this. The number is the number to guess, and we print the stats message, println. You used up. The message could be you used up number of tries and lost. Okay, so this is win or lose message with stats. So that's all I think, and we can just at the end also print a message that says the game is over. Game over, just like that, all caps. So that's all for this program. It's very easy, and we used loops, we used if statements, and we used conditions, we used the read from console thing. So it has a lot of things, or a lot of the things that we covered all in one program. And now we just need to link this to our menu thing. So 5 should be number guessing game, and we just have to say here 5, which will go to lecture 3 example 5, our brackets, and dot init. So that's all. Let's try our program and see if it works correctly. So we just run it. It will take a second to compile. Okay, so now it's working. We select 5 from the menu to go back to our, or to go to our game 5. Okay, so it's working. It says welcome to number guessing game. Please type your guess between 1 and 5. So I will guess that it's thinking 2 maybe, and it will tell me. Okay, I think I won. Congratulations, you won. The number is 2. Okay, on the first try you took 1 guesses to win. Game over. Okay, this is nice. It's kind of fun. So let's do it again. 5, and we'll go back to our number guessing game. So this time I will guess 3 and see. Okay, sorry, your guess is wrong. Your guess is higher than the number. Okay, so I have to go down. Maybe 2. Is it 2 again? You took 2. Okay, it was 2 again. So this game is a little cursed. But I noticed an issue. See here, the input on the second time is on a new line. So you have to go here in our while loop, and yes, we used the println. We have to use print so that it shows on the same line as this. So let's try again. Please type a choice. Okay, and wait a minute. You took 2 guesses to win. Oh, I thought we lost. Okay, so we won again. 5, and let's say 4. Your guess is higher than the number. Please tell me it's not 2. So let's say it's 3. Your guess is higher. Please, no. Okay, it's 1, I guess. It's 1, it's not 2. 1? Okay, it was 1. So this is fun. You took 4 guesses to win. Okay, so I won on the last attempt. And let me see if number of tries. So yeah, it's the last one. It's the last one. Okay, I need to pause this because it's still showing, so we need to compile it. So let's stop this and run it again so that this issue that we fixed is fixed. So we do 5, and now we are in our game. So I think let's go from 5. Okay, it says the guess is wrong, your guess is higher than the number. So let's go for, is it 4? Okay, it's still higher. I think 2, maybe 2. Oh my god, okay, last attempt, 3. And we won, yeah. The number is 3. You won, the number is 3. So let's try to lose this time. So we go 5 and see if the logic for our attempts works. So we can type number 5. It's not 5. Okay, it's not 5. I will keep typing 5. 5. So this should be my last attempt. Okay, and we lost. Yeah. It says, sorry, your guess is wrong. Sorry, you lost. The number is 4. And you used up 4 and lost. Okay, so here it should say attempts. So let us fix this. But everything else works just as expected. Where is it? It should be here. You took guesses to win. You used up attempts. You used up all of the 4 attempts. So it will say you used up all of the 4 attempts and lost. We can give it a try, and after that we will be done with this lecture. So let me go to the game 5, and we are in the game. So I will guess 5. Hopefully it's not 5. Okay, it's not 5. Another one, last attempt, and it says, sorry, you lost. The number is 4. Used up all the 4 attempts and lost, and the game is over, and we loop to the examples menu. Okay, so this works. It's really nice, and I'm very happy with it. Please, guys, practice and try to modify what we do in the lectures. Try to do things differently, or try to implement some new ideas based on what we learned. Of course, there are things that we have covered in the previous lectures, but we did not cover in these examples. But I trust that you will be practicing those on your own. So that is all for this time. And remember, on the internet, nobody knows that you are a potato, especially not a coding potato. And I would like to conclude with سبحانك اللهم وبحمدك أشهد أن لا إله إلا أنت أستغفرك وأتوب إليك.